All right, ninth graders, we are on page 61 in your math binder, and it is called Pet Sitting Task. So here's what you need to know. Alan is starting a pet daycare from his home. He has saved some money for the startup costs, and he has some friends in mind who have already asked him to watch their cats and dogs. Alan is trying to figure out the maximum amount of cats and dogs he can have at his daycare. Here's some important information to help Alan figure it out. First of all, a cat pen requires 6 square feet of space, and a dog pen requires 24 square feet of space. Also, Alan has 312 square feet of available space for cat and dog pens in his backyard. A cat pen costs $32 and a dog pen costs $80. And lastly, Alan has saved $1,280 for the purchase of cat and dog pens. If Alan needs to make sure that he has enough space for the cats and dogs and can afford to buy the pens for the cats and dogs, what is the perfect amount of cats and the perfect amount of dogs for Alan to watch at the pet daycare? Make sure that you're constructing viable mathematical arguments to share with the class about why your answer is the perfect combination. So I want you to have a number of cats and a number of dogs that are perfect together at Alan's daycare, where he totally maximizes his space and his cost efficiency. So I want you to pause the screen and try to come up with that amount. How many cats will it be? How many dogs will it be? Go. All right, so I'm guessing that many of you tried and maybe got a little bit frustrated with trying. Some of you might have never actually stopped the computer. Some of you might just be really confused about what you're doing right now. Let's try to brainstorm a little bit here. So if you're trying to find that perfect amount, some of you might be saying, okay, well, what if I were to have like 5 cats and I don't know, I'm just literally picking a number out of nowhere. If I had 5 cats and 7 dogs, just gonna try this. Okay, I know that a cat requires 6 square feet of space. So I've got 6 feet per cat, so 6 times those 5 cats, plus, how much was a dog? 24 square feet? Yeah, 24 times those 7 dogs. Remember, I'm looking for the perfect amount, and I want to know, does this equal 312? Okay, so 6 times 5. 6 times 5 plus 24 times 7 equals 198. So it doesn't equal 312, it equals 198. Did I utilize all the space properly? No, I did not. So how can I get one that does utilize all the space properly? So what if I were to choose, let's see, some of you might have found one that worked nicely. I want you to try this one. Let's do 4 cats and 12 dogs. So if I did 4 cats and 12 dogs, I'd be doing 6 times 4 plus 24 times 12. And let's see what that equals. 6 times 4 plus 24 times 12. And I get 312. Wow. Okay, so that took probably, for me, it took a long time to actually get that amount, 4 cats and 12 dogs. So now let's check it for the space or the money. We know a cat pen costs $32. So it's 32 times those 4 cat pens plus $80 times the 12 dog pens. I had 312 for the space. I'm hoping that I can get 1,280 so I can have the perfect cost. 32 times 4 plus 80 times 12, fingers crossed, 1,088. Not the perfect amount. So as much time as it took us to get that first one that worked, it didn't even work in the second equation. So we'd have to do all that work again and again and again. And this is called guessing and checking. And it's actually a very frustrating method, but it is an actual method in mathematics. You can guess and check and guess and check and guess and check and guess and check. And will it work? I will tell you, eventually it will work. It might take a very, very long time of guessing and checking. So that's why mathematicians sometimes start with guessing and checking, and then they start to see patterns. They start to see repetitions of some sort, and they try to make things more efficient. I am starting to see a little bit of a pattern with where I showed my work. Do you see how I have 6 times the cats plus 24 times the dogs, and 6 times the cats plus 24 times the dogs. And then with the money, it'd be 32 times the cats plus 80 times the dogs. That is a repetition. That is some sort of pattern. So some of you might have thought to make some equations or inequalities. So you might have said, let's let x equal cats and y equal dogs. And then you could set up this argument. You could say, well, 6 feet for every cat, 6 square feet, plus 24 square feet for every dog. And we want that to be equal to, now pause, before when we were doing inequalities, we would have said less than or equal to because that's your max space, but we're trying to find the perfect amount. So we actually are going to use equal to. And you could say that that equals 312 square feet of space. And then for the money, $32 per cat plus $80 per dog equals $1,280. So some of you might have written this out and you're like, yeah, this is great, but what do I do with this? This is just 2 equations. It doesn't tell me how many cats or how many dogs, which is why I want you to write down these equations because they are super helpful, but they are only helpful right now if we graph them. So we're going to take these down to this next problem, part B, and we are actually going to graph the inequalities. Or since we just got off of inequalities, I'm going to have a very difficult time stopping saying inequalities. So we've got 6x plus 24y equals 312. And I'm actually going to do this so I can write the other one on the other side because we're going to have to solve these for y. That's what makes it simpler to graph them. So the other equation is 32x plus 80y equals 1,280. Now, I always need to take this x and this y and put them on the x and the y axis. So number of cats, number of dogs, and let's start solving these inequalities. So on this first, equations, on this first one, I'm going to subtract 6x from both sides, and I would get 24y equals negative 6x plus 312. I can divide by 24, divide by 24, divide by 24. Okay, then I have y equals, and when I reduce the fraction, negative 6 over 24, those are both divisible by 6. So negative 6 divided by 6 would give us negative 1. 24 divided by 6 would give us 4. So negative 1/4 x. I don't know 312 divided by 24 off the top of my head. It is 13, so plus 13. Okay, then we can graph that. Let's graph that by putting our first dot at positive 13, and then I go down 1 to the right 4, 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 and down 1 to the right 4. Okay, let's connect those dots. And there's our first graph. Let's get the second one graphed. I'm going to solve for y first. Subtract 32x from both sides of the equation. I wrote 3x, that's a 32. And then I have 80y equals negative 32x plus 1,280. Divide by 80, divide by 80, divide by 80. Okay, I have y equals negative 32 divided by 80. And we have negative 2/5. So negative 2/5 x, and then 1,280 divided by 80 is 16. So plus 16. So I can put my dot at 16, and I can go down 2 to the right 1, 2, 3, 4, 5. Down 2 to the right 1, 2, 3, 4, 5. Down 2 to the right 1, 2, 3, 4, 5. Down 2 to the right 1, 2, 3, 4, 5. And that's the last one that I can fit. All right, we can see that these cross very nicely. I can put arrows on these. These cross very nicely at this ordered pair. The ordered pair here is 20, 8. So here is a common mistake that a lot of people make when they are doing these. Let me pause for 1 second. All right, so we've got these things, they're crossing at 20, 8. Now that's 20 on the cat side, and that is 8 on the dog side. Sorry, someone came in here, which is why I was still wearing a mask. So if you were to go back to Alan and say, Alan, 20, 8, he'd look at you like you're slightly insane, because that's not putting this back in context of the problem. So you are going to write a sentence as your solution. You are going to say, Alan can have 20 cats and 8 dogs. So whenever you have these word problems like this, where you're having a system of equations with a story, you need to have a story answer. You need to have an answer that puts it back in context. So on these, I want you to remember where you find the solution. So remember when we were graphing, we said our double shading region was the solution with the inequalities. Well, here, the solution is where the lines cross. So I'm going to write where the lines cross. When you are graphing a system, your solution is where the lines cross. All right, good luck on the rest of your work, 9th graders.